Hello there, and welcome to The Calm Scientist. Tonight, we will embark on a quiet journey, drifting gently away from the warm, familiar glow of our own world. We will float past the silver-lit clouds, beyond the silent watch of our moon, and into the deep, endless void of space. Allow the thoughts and pressures of the day to simply melt away. Feel your body growing lighter, more relaxed, as your mind begins its voyage to the farthest reaches of the cosmos, to places where light itself takes thousands of years to travel. Tonight, we are going to seek out the true giants of the universe. Not the great gas planets, but the stars. Colossal nuclear furnaces, so immense they make our own sun, the life-giving heart of our solar system, seem like a tiny, forgotten speck of dust. This journey will guide us through the 10 largest stars known to humankind. We will begin with the smallest of these titans, and slowly, peacefully, make our way to the very largest, the true Leviathan of the galaxy. But before we begin, we need a sense of scale, a reference point to truly appreciate the immensity we are about to witness. Let us first take a moment to consider our own star, the Sun. Imagine the Sun in your mind's eye. Its radius is nearly 700,000 kilometers. It is a number so vast it can be hard to grasp. So instead, picture this. If you were to line up planets, just like our Earth, side by side, you would need 109 of them to stretch across the Sun's diameter, a string of planetary pearls. And if you were sitting on a passenger airliner traveling at 800 kilometers per hour without stopping, it would take you around 8 months, 8 continuous months to fly just once around its equator. The journey of over 3 million kilometers. Its volume is even more staggering. You could fit approximately 3 million Earths inside the Sun, like tiny marbles in a vast, glowing globe of glass. Think on that for a moment. 3 million of our own worlds, all held within that great ball of fire. Hold that image in your mind. This immense, life-giving star, the center of our world. Because now, our journey truly begins. Our first star on this countdown, resting at number 10, is a familiar name to those who gaze at the night sky. It is Antares, known as the heart of the Scorpion. It is a brilliant red point of light in the constellation Scorpius. Its name means rival of Mars, for its deep crimson hue that competes with the red planet in the heavens. Antares is a red supergiant, a star in the twilight of its life. Like a flower blooming to its fullest just before it fades, it has swelled to a truly astonishing size. With a radius around 700 times greater than our Sun, it is no longer a small, distant point. If we were to place Antares where our Sun is now, its surface would not just swallow Mercury and Venus. It would engulf our own planet, Earth. Its fiery edge would stretch far beyond the orbit of Mars. Imagine for a moment our world no longer bathed in gentle sunlight, but deep within the glowing atmosphere of a giant star. A truly humbling thought. And now, let us drift onward. Leaving the heart of the Scorpion behind, we travel deeper into the darkness towards a beacon that shines even larger, even brighter. The star at number 9 on our list is Betelgeuse. This name may be even more familiar. Betelgeuse is the glowing red shoulder of the constellation Orion the Hunter, one of the most recognizable and brilliant stars in our night sky. Like Antares, Betelgeuse is a star nearing the end of its magnificent life. The nuclear reactions in its core have changed, causing its outer layers to expand to an extraordinary degree. Its radius is nearly 900 times that of our Sun. A vast globe of gas, pulsating gently, like a colossal heart. If Betelgeuse were our star, it would swallow the entire inner solar system, and its surface would reach far into the asteroid belt, perhaps even grazing the orbit of Jupiter. Scientists watch Betelgeuse with a quiet fascination. They know that someday in the distant future, perhaps tomorrow, perhaps in 100,000 years, it will end its life in a spectacular supernova, lighting up a corner of our galaxy for weeks on end. But for now, it hangs in the sky like a giant cosmic ruby, a peaceful reminder of the grand cycle of life and death throughout the universe. We have met 2 of the giants, but our journey has only just begun. Ahead lie stars far larger still. So large that Antares and Betelgeuse would seem like little brothers beside them. Take a deep, slow breath. And allow your mind to continue its gentle drift. For in our next part, we will meet the first stars to cross the threshold of 1,000 suns in size. We visited the heart of the Scorpion, the fiery red supergiant Antares, a star so large it would swallow our planet and Mars without a second thought. Then, we floated to the shoulder of Orion to gaze upon the majestic Betelgeuse, whose surface would stretch far beyond the asteroid belt, reaching for the domain of Jupiter. These stars, with radiant hundreds of times that of our Sun, felt impossibly large. But they were merely the gatekeepers on our journey. Tonight, we leave them behind, like gentle, blowing beacons in our wake, and venture further into the deep. Towards a new class of Titan. Breathe slowly. And feel yourself drifting once more into the silent, star-strewn darkness. Tonight, we cross a threshold. We will now meet the stars whose size is not measured in hundreds, but in thousands of suns. Our next destination lies in a beautiful and dense region of the sky. Following the luminous river of the Milky Way, we arrive at the constellation Sagittarius, the Archer. This is a special place in our night sky, for when you look towards Sagittarius, you are looking towards the very heart of our galaxy. It is a region crowded with ancient stars, swirling nebulae, and untold mysteries. And nestled within this cosmic tapestry, at number 8 on our list, we find a star named Sagittarius. Let us approach this giant with the same quiet reverence as before. At first, it appears as another point of deep, ruby red light, much like Antares. But as we draw closer, its true nature unfolds. The Sagittarius is a supergiant with a radius estimated to be around 1,000 times that of our own Sun. Let us pause here and truly consider what this means. We have just crossed into a new realm of immensity. Remember the 109 Earths lined up across our Sun's diameter. To cross the diameter of Sagittarius, you would need to line up over 109,000 Earths, and our tiny passenger plane, which took 8 months to circle the Sun, would now need more than 60 years of continuous flight to complete a single journey around this star, a lifetime spent just to circumnavigate its glowing equator. If Sagittarius were to take the place of our Sun, its presence would be overwhelming. Its surface would not just reach Jupiter, as Betelgeuse nearly did, it would completely consume it. The largest planet in our solar system, the gas giant itself, would become nothing more than a momentary ripple on the surface of this colossal star. Its fiery atmosphere would extend halfway to the orbit of Saturn. Our solar system would be transformed into an inner sanctum of a single, impossibly large world of fire. But the most fascinating thing about stars like Sagittarius is not just their size, but their substance. A star this large is not a dense, solid ball. Its outer layers are incredibly thin and diffuse. It is less a solid object and more a vast, glowing cloud, held together by a gravitational core that is almost incomprehensibly far away. The gas at its surface is thousands of times less dense than the air you are breathing right now. It is a ghostly giant, a phantom of fire whose edges blur into the vacuum of space. And from these ethereal edges, Sagittarius is constantly releasing a part of itself into the cosmos. This is known as the stellar wind. It is not a violent gale, but a slow, steady sigh of particles, flowing outwards for millions upon millions of kilometers. Over the course of its life, this gentle, cosmic exhalation carries away vast quantities of matter, the very elements forged in its heart. These elements, like carbon, oxygen, and iron, will one day drift through the galaxy, seeding new clouds of gas and dust from which new stars, new planets, and perhaps new life will one day be born. The Sagittarius is not just a giant, it is a galactic gardener, quietly scattering the seeds of future worlds. Let us float here for a moment in the gentle, ruby-hued light of this star and feel the silent, creative power of the universe at work. The cycle of creation and dissolution, played out on a scale that defies our everyday imagination. And now, let us continue our journey. We leave the crowded heart of the galaxy behind and travel towards another graceful constellation, one that appears to be flying down the very spine of the Milky Way. This is Saturnus, the Swan. And within its wings, we find our next destination, the star at number 7 on our countdown, Cygni. As we approach, we see another magnificent red supergiant, even larger than the one we just left. The precise measurements of these distant giants are a profound challenge for astronomers. They are so far away, their light often obscured by veils of interstellar dust, and their own atmospheres are so diffuse that it is hard to say where the star truly ends and space begins. But the most reliable estimates place Cygnus' radius at approximately 1420 times that of our Sun. It may be even larger, with some studies suggesting it could be over 2800 times the Sun's radius, but we will remain with the more conservative figure for our peaceful journey tonight. At 1420 solar radii, this star is a true behemoth. Let's return to our familiar solar system one last time. If Cygnus were at its center, its surface would extend far beyond the orbit of Jupiter. The next planet, Saturn, with its beautiful, iconic rings, would find itself perilously close to the star's edge, its rings vaporized and its atmosphere stripped away by the intense heat and stellar wind. The solar system as we know it would be gone, replaced by the sheer, overwhelming presence of this single star. Its volume is almost beyond comprehension. We learned that 3 million Earths could fit inside our Sun. To fill the volume of Cygnus, you would need nearly 3 billion suns. Billions of our own life-giving stars poured into this one cosmic vessel. Another fascinating quality of Cygnus is its variability. It is not a star that shines with a steady, constant light. Instead, its brightness gently swells and recedes over hundreds of days, like a slow, rhythmic breath. This pulsation is common in aging supergiants. Their vast, unstable atmospheres expand and contract, causing their temperature and luminosity to change in a slow, cosmic dance. Watching it is like watching the universe itself breathe. But a slow, deep, and ancient rhythm. This variability, combined with its great distance of about 5,000 light-years, makes studying Cygnus a delicate art. Astronomers must peer through the cosmic haze, carefully measuring the faint, reddened light that has traveled for millennia to reach us. Every photon of light from Cygnus is a messenger from the distant past, telling a story of a star so large, so luminous, and so different from our own. Its color is a deep, smoldering red, indicating a surface temperature that is much cooler than our Sun's. While our Sun's surface burns at around 5,500 degrees Celsius, Cygnus is a mere 3,200 degrees. It is a cool giant, but its sheer size means it radiates an incredible amount of energy. Its luminosity is hundreds of thousands of times greater than that of our Sun. It is a powerhouse, a furnace of unimaginable scale, yet it burns with the slow, deep glow of ancient embers. We have now traveled far and met 4 of the universe's great giants. We have left the familiar scale of our solar system far behind and have journeyed into a realm where stars are measured in thousands of suns, where planets would be consumed like moths in a flame, and where the stars themselves breathe in slow, ancient rhythms. But our journey is not yet over. There are still greater giants to behold. The stars that lie ahead of us on this list are so extreme, so colossal, that they challenge the very limits of how we believe a star can exist. They are the true kings of the cosmos. So for now, rest. Allow your mind to float in the vast, quiet space between these worlds of fire. Let the deep, crimson glow of these distant suns be a gentle nightlight for your dreams. And when you are ready, we will continue our journey. Together. In our journey so far, we have recalibrated our sense of wonder. We began with our Sun, a star capable of holding 1 million Earths, and found it to be a humble starting point. We have since visited the magnificent red supergiants Antares and Betelgeuse, whose sizes would engulf the inner planets of our solar system. We then crossed a new frontier, meeting Sagittarius and Cygnus, titans whose radii are 1,000 times or more that of our own Sun, their surfaces extending far beyond the orbit of Jupiter. We have witnessed stars that breathe, pulsating with a slow, ancient rhythm, and stars that are cosmic gardeners, gently seeding the galaxy with the elements of future worlds. But the universe is ever ready to expand our sense of the possible. The stars we are about to visit are of a different class entirely. They are known as supergiants. These are not merely larger versions of the stars we have seen. They are among the most massive, most luminous, and most unstable stars in the entire universe. They live fast, burn ferociously, and die young in spectacular cosmic displays. They are the ephemeral kings of the stellar world, and our next destination is one of the most famous among them. Let us turn our attention now to a different corner of the sky, to the constellation known as Canis Major, the Great Dog. Here, following the bright lead of the star Sirius, we find a much fainter, much redder object. It does not stand out to the naked eye. In fact, you would need a telescope to see it. But what it lacks in apparent brightness, it makes up for in sheer, mind-ending size. This, at number 6 on our list, is the legendary Canis Majoris. For a long time, Canis Majoris was considered the largest star known to humanity. Modern measurements have since revised its size, placing other stars ahead of it, but its legacy as a cosmic monster remains. Its estimated radius is still a staggering 1420 times that of our Sun, placing it in the same league as Canis. But Canis Majoris is a far more violent and chaotic star. As we draw closer, we see that it is not a perfect, serene sphere of light. Instead, it is surrounded by a vast, intricate nebula of its own making. This is not the gentle stellar wind of a calmer supergiant. This is the result of colossal, violent eruptions from the star's surface. Over the past few thousand years, Canis Majoris has been tearing itself apart. It has ejected huge, asymmetric clouds of gas and dust into the space around it, forming immense arcs, filaments and clumps that extend for trillions of kilometers. These structures are so large that it takes light years to cross them. The Hubble Space Telescope has given us breathtaking images of this nebula, revealing the star not just living, but actively dying in a magnificent, drawn-out spectacle. Imagine watching a volcano erupt, but on a stellar scale. Blobs of matter, many times the mass of our own moon, are violently thrown from its surface, traveling outwards at incredible speeds. This star is so unstable that it has lost a significant portion of its original mass, perhaps as much as half of it, in these dramatic eruptions. All this ejected material forms a thick, dusty cocoon around the star, which makes it difficult for astronomers to see its surface directly and measure its size accurately. The light we see has been scattered and dimmed by its own self, age shroud. Facing this chaotic giant in our solar system would create a scene of unparalleled cosmic drama. Like the others in this class, it would engulf the planets out to Jupiter. But unlike the gentle pulsations of Canis, the environment around Canis Majoris would be a tempest. Colossal shockwaves and clouds of superheated gas would sweep through what remains of the outer solar system. It would be a place of violent, unpredictable, and awesome power. The very existence of Canis Majoris pushes the boundaries of our understanding of stellar physics. How can a star become so large and yet so unstable? What drives these colossal eruptions? Scientists believe that it is a star very near the end of its life, perhaps only a few 100,000 years away from its final, cataclysmic supernova. When it does explode, it will likely be one of the most powerful supernovae our galaxy has seen in modern times. It may even result in a hypernova, an explosion so energetic that it creates a gamma-ray burst, beaming intense radiation across the galaxy. But for now, it remains a cosmic enigma, a veiled giant, furiously casting off its own substance into the void. It is a star that reminds us that the universe is not always a place of serene, clockwork motion, but also a place of raw, untamable and creative violence. Let us pause in the turbulent space surrounding this hypergiant and feel the sheer power contained within it. A power that both creates the elements of life and destroys everything in its path. Now, with that image of cosmic fury fading gently into the background, let us continue our peaceful voyage. We travel a great distance now, nearly 20,000 light-years from our home, to another dense and dusty region of the Milky Way in the constellation Scutum, the Shield. Here, hidden within a cluster of other massive stars, we find our fifth, Lace star, a truly monumental object known as Stephenson 218. We have now arrived at the current reigning monarch of the stellar giants. As of our journey tonight, Stephenson 218 is widely considered to be the largest known star in the universe. As we approach this star, the sense of scale we have so carefully built begins to shatter. The numbers become almost abstract, the comparisons almost fantastical. Stephenson 218 is a red hypergiant with an estimated radius of 2150 times that of our Sun. Let this number sink in for a moment. 2,150. Remember our Sun, which could hold 3 million Earths. The volume of Stephenson 218 is so vast that it could hold nearly 10 billion suns. Billions. Take every single star you can see in the night sky with your naked eye, and you could fit all of them, thousands of times over, inside this single star. If we were to place Stephenson 218 at the heart of our solar system, the result would be almost unthinkable. Its surface, its photosphere, would not just swallow Mercury, Venus, Earth, Mars, and Jupiter. It would extend past the orbit of Saturn. The glorious rings of Saturn, stretching hundreds of thousands of kilometers into space, would be deep inside the star's fiery atmosphere. The edge of the star would be somewhere between the orbits of Saturn and Uranus. Our entire planetary neighborhood, the setting of all human history and exploration, would be consumed. Let us return one last time to our imaginary airliner. To fly around the equator of Stephenson 218 would take our plane not years, not decades, but centuries. At 800 kilometers per hour, the journey would last for more than 900 years. A single trip, spanning the rise and fall of empires on our distant, long-swallowed Earth. The light from this star, as it travels from one side to the other, would take nearly 9 hours to complete its journey. By comparison, light takes only 8 minutes to travel from the Sun to the Earth. And yet, for all its incomprehensible size, Stephenson 218 shares the same ghostly nature as the other giants we have met. It is a star of incredibly low density. Its mass is estimated to be only about 40 times that of our Sun. All that mass is spread out over a volume so enormous that the outer layers are an almost perfect vacuum, far less dense than the thinnest air in Earth's upper atmosphere. It is a cosmic bubble of unimaginable proportions. Like Vi Canis Majoris, Stephenson 218 is shedding its mass at a prodigious rate, enriching the interstellar medium around it. It is also a very cool star, with a surface temperature similar to that of Cassini, giving it that deep, ruby-red glow. But its sheer surface area is so vast that its total luminosity is nearly 500,000 times that of our Sun. It is one of the most luminous cool hypergiants known. To gaze upon Stephenson 218 is to confront the absolute extremes of what the universe can create. It is a star that exists on a scale so far removed from our own that it forces a profound sense of humility and wonder. It is a quiet, distant monarch, reigning over a kingdom of fire so vast that our entire solar system would be but a footnote within it. We have now reached the halfway point of our journey, and have stood in the presence of the largest known star. The stars that remain on our list may not be larger, but they are giants in their own right, each with a unique story and a unique place in the cosmic hierarchy we have been exploring. For now, let us find a quiet place in the void, far from the overwhelming glow of Stephenson 218. Let the image of its impossible size dissolve into the peaceful darkness of your mind. Let your thoughts be as vast and as quiet as the space between the stars. As we reconvene in the quiet theatre of the night, allow your mind to settle once more into a state of peaceful observation. Our journey has taken us through realms of unimaginable scale. We have floated past stars that could swallow planets and asteroid belts and stood in the silent, humbling presence of Stephenson 218, a star so vast its surface would reach the orbit of Saturn. We have seen that size in the cosmos is a strange and ethereal thing. These giants are not solid, dense objects, but diffuse, glowing clouds of gas held together by a distant gravitational heart. They are ancient, unstable, and live their lives on the very edge of what is physically possible. Having met the reigning monarch, one might think our journey of discovery is nearing its end. But the universe is full of nuance and mystery. The stars that occupy the final places on our list are not necessarily smaller, but their stories are more complex, their natures more debated, and their true size is shrouded in even greater uncertainty. They are the outliers, the cosmic enigmas that remind us how much we still have to learn. Let us now gently push away from the overwhelming presence of Stephenson 218 and set a course for the constellation Cygnus once more. We have visited the Swan before, to see the magnificent Cygni, but this time, we are looking for something far more elusive, a star that holds the number 4 spot on our countdown. It is a star known as Nil Cygni. At a distance of approximately 5,300 light-years, Nil Cygni is another red hypergiant and a very special one at that. For a time, it, too, held the title of the largest star known. Its estimated radius is about 1640 times that of our Sun, smaller than Stephenson 218, but still firmly in the upper echelons of stellar giants. A star of this size would, like its brethren, comfortably swallow Jupiter and reach more than halfway to Saturn. But what makes Nil Cygni so profoundly interesting is not just its size, but what surrounds it. Like Vi Canis Majoris, it is enshrouded in a thick, dusty nebula of its own creation. This circumstellar envelope is so dense that it obscures almost all of the star's visible light. If you were to look at Nil Cygni through a standard optical telescope, you would see very little. It is a giant hiding in plain sight. The light that does reach us is mostly in the infrared spectrum, a light of heat. To truly see Nil Cygni, astronomers must use telescopes that can detect this infrared glow, peering through the dust to the furnace hidden within. This dust is not just a formless cloud, it has a fascinating, bean-like shape, and it is rich in complex molecules, including water. In fact, Null Cygni is what is known as an oxygen-rich star, and it is surrounded by one of the most massive envelopes of water vapor ever discovered around a star. It is a cosmic water factory, continuously pumping out vast quantities of WU into the space around it. This water, of course, is not liquid, but superheated steam. But it is a powerful reminder that the fundamental ingredients for life, as we know it, are not unique to our quiet corner of the galaxy. They are forged and distributed by these very giants. The star is also a semi-regular variable, meaning its brightness changes over a period of about 940 days, but without the perfect, clockwork rhythm of some other variable stars. This adds to the challenge of studying it. Its pulsations, its dusty veil, and its great distance all conspire to keep its truest nature a secret. Floating near Null Cygni would be a strange experience. You would be immersed in a thick, warm fog of dust and gas. The star itself would not be a clear, defined orb, but a great luminous heart, beating with a soft, ruddy light, its form blurred and softened by the very air of space. It would feel less like being next to a star and more like being inside a vast, cosmic womb, where the elements of creation are being slowly nurtured and prepared for their journey into the galaxy. Let us rest here for a moment, in this dusty, hidden sanctuary, and contemplate the unseen. The universe is not just what we can see with our eyes, but also what we can perceive through other forms of light, other senses. Null Cygni is a testament to the hidden beauty and complexity that lies just beyond the veil of the visible. And now, our journey takes another turn. We have been visiting stars that are still shining, still in the final, glorious stages of their lives. But for our star at number 3, we must look for something different. We are not looking for a point of light, but for the ghost of a star that was once among the largest in the entire galaxy. We are searching for WOG-64. Located in the Large Magellanic Cloud, a small satellite galaxy that orbits our own Milky Way, WOG-64 is about 160,000 light-years from Earth. It is another red hypergiant, and its story is one of cosmic struggle and debate. For many years, estimates of its size were truly colossal, placing it far above any other known star, with a radius thought to be as much as 3,000 times that of our Sun. A star that large would extend beyond the orbit of Saturn. However, more recent and refined observations have brought this number down significantly. The current consensus is that the star itself has a radius of about 1540 solar radii. So why the initial, much larger estimate? It is because WOG-64 is not just a star, it is a star surrounded by an enormous, thick, and opaque torus or donut shape of dust that it has ejected. This dusty ring is so massive that it contains between 3 and 9 times the mass of our Sun. The star has shed its own substance to create this obscuring cloud. The initial measurements were likely detecting the outer edges of this dusty torus, not the surface of the star itself. It took the power of advanced telescopes, capable of peering through the dust, to distinguish the star from its surrounding shroud. Even at its revised size, WOG-64 is a true giant. But its story is a perfect example of the challenges of stellar astronomy. Measuring these distant objects is an act of cosmic archaeology, piecing together clues from faint, ancient light that has been altered by its long journey through space. WOG-64 is also a star that is living on borrowed time. It is shedding its mass at such an incredible rate that it is expected to explode as a supernova in just a few thousand years, mere blink of an eye in cosmic terms. When it does, its final, brilliant flash of light will take 160,000 years to reach us. So, it is entirely possible that the star we are observing tonight has already died. We may be looking at a ghost, a memory of light from a long, vanished titan. This thought adds a profound layer of stillness to our journey. We are not just traveling through space, but through time. The universe we see is a tapestry of past and present, a collection of stories whose final chapters may have already been written, long before their light ever reached our eyes. Let us float here, in the space between galaxies, and gaze at this distant, dusty giant. Let us appreciate the patience and ingenuity of the scientists who worked to uncover its secrets, and let us feel a sense of connection to the deep, unfolding story of the cosmos, a story that we are only just beginning to read. Our journey is drawing closer to its conclusion. We have navigated by the light of giants and the infrared glow of hidden furnaces. We have contemplated the violent death of stars and the silent, patient journey of light through the void. Only 2 stars remain on our list, 2 final titans to complete our tour of the immense. Our quiet voyage is nearing its end. Together, we have drifted through the silent depths of space, seeking out the grandest and most magnificent stars our universe has to offer. We have learned that our own sun, a star of immense power, is but a dwarf in a cosmic landscape populated by true giants. We have visited the smouldering red supergiants Antares and Betelgeuse. We have crossed the sun threshold to witness the grandeur of Sagittarius and Cygni. We have faced the chaotic, self-destructive fury of the hypergiant Vicanis Majoris and stood in awe of Stephenson 218, the largest known star, a titan whose size would consume our solar system out to the orbit of Saturn. We have peered through veils of cosmic dust to find the hidden furnaces of Nimble Cygni and contemplated the ghostly light of Woji 64, a star that may have already met its end thousands of years ago. Our journey has been one not just of scale, but of understanding. We have learned that these colossal stars are ethereal and diffuse, living short, brilliant lives before seeding the cosmos with the very elements that make life possible. They are the great ancestors of the galaxy. And now, as we begin the final leg of our journey, let us take a moment to feel the profound stillness of the void one last time. Feel the gentle pull of distant gravity, the faint whisper of ancient light on your closed eyelids. There are 2 final stars on our list. 2 more titans to visit before we begin our journey home. Our destination for the star at number 2 takes us far from the familiar arms of the Milky Way, to the constellation Tucana, visible from the southern hemisphere. Here, we are not looking for a single star, but for a faint smudge of light known as the Small Magellanic Cloud. This is another satellite galaxy of our own, a cosmic neighbor, and within it, we find our star, Westerland 126. This star is part of a superstar cluster, one of the most massive young clusters in our local group of galaxies. It is a stellar nursery of giants, a place where the most massive and luminous stars are born together. Westerland 126 is one of its most distinguished residents. It is another red hypergiant, and a particularly luminous one. Its estimated radius places it at around 15-30 times that of our Sun. While slightly smaller than Woji 64, its place on this list is secured by its sheer power and the fascinating environment it inhabits. If it were in our solar system, its surface would lie somewhere between the orbits of Jupiter and Saturn, a familiar scale for the giants we have met tonight. But what is truly remarkable about Westerland 126 is the story it tells about the life of the most massive stars. It is so luminous and so massive that it is constantly fighting against its own gravity. The outward pressure of the light it generates is so intense that it is blowing its own atmosphere away into space at an incredible rate. Surrounding the star is a vast, glowing nebula, an ionized nebula, created when the star's own powerful radiation excites the very gas it has expelled, causing it to glow like a cosmic neon sign. It has created its own beautiful, ethereal shroud. Even more fascinating, in 2013, astronomers discovered something extraordinary, a long tail of glowing, ionized gas stretching away from the star for more than a light year. This is a radio nebula, visible only to radio telescopes. It seems that Westerland 126 is not just passively losing its mass, it is actively shaping the space around it, leaving a luminous trail as it moves through its home cluster. This star is a perfect illustration of the final, dramatic stages of a massive star's life. It has burned through the hydrogen in its core, swelled into a giant, and is now desperately trying to shed its outer layers before its inevitable collapse. Like all the hypergiants we have visited, it is destined for a supernova explosion. When that happens, it will send a cataclysmic shockwave through the Westerland 1 cluster, triggering a new wave of star formation and continuing the grand, cosmic cycle of birth, death, and rebirth. To be near Westerland 126 is to be in a place of both beauty and tension. The glowing nebula would paint the surrounding space with soft hues of red and green, but you would feel the immense, restless power of the star at its heart, a giant struggling to maintain its own equilibrium, a king preparing for its final, magnificent act. And now, we come to the end of our list, to the star that holds the number 1 position. But here, our journey takes a final, contemplative turn. For the largest star is not a different one, but the one we have already met. It is Stephenson 218. We place it here, at the end of our journey, not just as a matter of ranking, but as a final, quiet destination, a place to return to fully absorb the meaning of what we have seen. Let us drift back to the constellation Scutum and approach this ultimate titan one last time. At 2150 times the radius of our Sun, it represents the absolute upper limit of how large a star can be. Any larger, and its own luminosity would tear it apart. It exists in a delicate, precarious balance between the inward crush of gravity and the outward force of its own light. There are no adequate words, no earthly comparisons that can truly capture its scale. To be in its presence is to feel a sense of profound, silent awe. All the stars we have visited tonight, Antares, Betelgeuse, Canis Majoris, are giants, but Stephenson 218 is a giant among giants. It is a quiet king, reigning over a vast, empty region of space, its deep red light traveling for 20,000 years to reach our world. It is a living, breathing testament to the sheer, creative power of the cosmos. It reminds us that for all we have learned, for all we have measured, the universe will always hold wonders that lie beyond our comprehension. And so, here, in the gentle, ancient light of the largest known star, our journey concludes. We have traveled across galaxies, peered through dust clouds, and witnessed the birth and death of worlds on a scale that transcends human experience. It is time to return. Let the image of these great stars fade, not into nothingness, but into a quiet corner of your memory. Let them become a part of your inner landscape, reminder of the vastness, the beauty, and the profound mystery of the universe of which you are a part. Begin to feel yourself drifting back now. Back through the star fields. Back through the arms of our own Milky Way. Past the familiar constellations. Past the orbits of the outer planets. Past the silent watch of our moon. And back into the gentle, quiet atmosphere of Earth. Feel the weight of your body again, resting comfortably, securely. Become aware of the gentle rise and fall of your own breath. A rhythm so much faster, yet just as profound, as the breathing of the stars. The giants of the cosmos are distant, but their story is our story. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in the hearts of stars like these, long ago. We are, in the most literal sense, the children of the stars. And as you drift now into a deep and peaceful sleep, may you carry that connection with you. May you dream of crimson giants and swirling nebulae, and may you awaken with a renewed sense of wonder for the magnificent, mysterious, and beautiful universe you call home. Thank you for joining me on this journey. Sleep well.